Okay, so to reiterate, you have two SIM cards, SIM1 and SIM2. The calling plan from SIM1 is 1 paisa throughout, and calling plan from SIM2 is increasing in this way. So these are the marginal costs of calling. So how would you choose the number of calls made from SIM1? Suppose you have to make a total number of calls C. How would you choose C1 and C2?
So we can make one call from SIM2 and others from SIM1.
Yeah, or equally easier thing would be to just make all calls from SIM1 and just make no calls from SIM2. Okay. So here the thing is that SIM1 is cheaper throughout. But if I change this and make this, let's say, 5 paisa for all calls. Okay, so SIM1 is costing you 5 paisa for all calls. Now, how would you divide your calling between the two SIM cards?
So first and second from SIM2 and then others from SIM1.
Okay, yeah. So C2 is going to be 2 if total calls are greater than or equal to 2. Otherwise, it's just going to be equal to C if C is less than 2. And C1 is going to be C minus 2 if C is greater than or equal to, and 0 otherwise if C is less than. So that's a complete characterization, but you understand the first two calls come from SIM2 because this is cheaper. After that, this is cheaper. So all the subsequent calls will come from SIM1. So this is how you need to think about production also. So whenever you are thinking about production, if you think in terms of, let's say you have to make some calls and which SIM you are going to pick. So you can imagine it like that way, and maybe the job becomes easier for you. All right. So the rule of thumb is when you have increasing marginal cost MC1 and MC2, and you have to produce a total quantity Y, which is, let's say, Y1 plus Y2, then Y1 and Y2 will be such that marginal cost in plant 1 for production Y1 should be equal to marginal cost on plant 2 for production Y. Okay, so if this is your MC1 and MC2 graphs, then Y1 and Y2 should be chosen in such a way that the marginal cost becomes equal. So let's do a simple example first to understand this concept. So the example is, suppose you have a marginal cost in plant 1 equals to Q1 and marginal cost in plant 2 equals to Q2. Yeah, no, 2Q. So how will you divide a total quantity Q in Q1 and Q2 in this setup? So the solution is very straightforward. First of all, what are my unknowns here? What are the things that I want to find here?
Q1 and Q2.
Very good. Capital Q is not an unknown. Capital Q is a known variable. Suppose you are given a contract to produce a quantity Q. How are you going to separate this quantity Q in the two plants Q1 and Q2? So I need Q1 and Q2 as functions of capital Q. So capital Q is not an unknown. Okay, so I always keep telling you this. First, focus on what are the things that you have to find. So you have to find two things, Q1 and Q2. So I need two equations for Q1 and Q2. First equation is Q1 plus Q2 must be equal to capital Q. And second equation is the one I just defined, that MC1 at Q1 must be equal to MC2 at Q2. So if I use these two equations, I can find Q1 and Q2. Right? So if I use this, substitute this thing here, I get 3Q2 equals to Q, which implies Q2 equals to capital Q by 3, which implies Q1 equals to 2 capital Q by 3. So So that's your complete production function. Sorry, production distribution between plants. Now, let's look at this example. You guys are going to do this example. A firm has two plants to produce an output, each with production function Qi equals to under root Ki Li. Okay. So Q1 equals to under root K1 L1. Okay, he's also given me K1 is 25, K2 is 100. So this is under root 25 L1. And Q2 is equals to under root K2 L2. So that is under root 100 L2. He's asked us to assume that both the input prices are 1. So that eases up the calculation. This is called normalization. It's a technique we use very often just to ensure that calculations are easy. If an entrepreneur wishes to minimize short-run total cost of widget production, how should the output be allocated between the two firms? So what I need right now is short-run marginal cost in plant 1 as a function of Q1 and short-run marginal cost in plant 2 as a function of Q2. So that is what you guys need to get. So W equals to V. V is basically rental rate, which is 1. So so that will ease up your calculations. So tell me what are going to be the short-run marginal costs.
So is it short-run cost 1 is Q1 square by 25 plus 25? That is short-run cost, not the marginal cost. The
1
margin
square by 25 plus 25. That is
25.
short-run cost.
Yeah. So short-run cost will be 2 Q1 by 25. Marginal cost. And
Okay.
the short-run cost 2 is Q2 square by 100 plus 100. And marginal cost will be 2, that is Q2 by 50.
Right. Is everybody getting this? Has everybody got this one at least? No doubts here. Okay, fine. So now that you have your short-run marginal cost, for any quantity Q, what is going to be Q1 and Q2? These are your short-run marginal costs.
So where both the costs will be equal.
Yeah, I'm asking quantities as a function of capital Q. I'm not asking descriptive answers. I'm asking you final answer like I gave here. Q1 equals to 2Q by 3, Q2 equals to Q by 3. That's what I'm looking for.
So Q1 is equal to capital Q by 5.
Okay.
And Q2 is equal to capital Q by 20.
Capital Q by.
20.
So if I add them up, am I getting capital Q?
Oh,
I
wait.
don't think.
Yeah.
So
So
once you reach
by
this
5.
point,
That is 4
after
Q by
that, it is fairly straightforward. After you reach, you found these out, you are just going to use these equations. Okay, Q1 plus Q2 equals to capital Q, and marginal costs are equal. So 2Q1 by 25 should be equal to Q by 50, Q2 by 50. So this cancels with this. This becomes 2. So this becomes Q2 equals to 4 times of Q1. And then you substitute this here. So you get 4Q1. So 5 times Q1 equals to Q, implies capital Q equals to, no, implies Q1 equals to capital Q by 5. So this is capital Q by 5 and Q2 is 4 times that. So this becomes 4 capital Q by 5. So that's your final answer. Okay, so as far as exams are concerned, this is probably the most difficult thing they would ask you. Obviously not exactly these numbers. The numbers would be different, but we are going to take one level up and do some more complicated examples just to prepare ourselves for those situations. Suppose a firm has two plants. Plant A has no fixed cost of operation and a marginal cost of C1 equals to Q1. So marginal cost of plant 1 is plant B has cost function C2. The cost function of this guy is C2 equals to 1 plus 2Q2 square. Okay, so I should have used MC1 here. Sorry for that. Anyway, I have clarified that this is the cost function, whereas this is the marginal cost function for plant 1. So the cost function for plant 2 is C2 equals to 1 plus Q2 square. If Q2 equals to 0. If Q2 is greater than 0, and the cost of plant B goes to 0 if Q2 equals to 0. This should be a bunch of discrepancies here. This should be Q2. So this is 0 if Q2 equals to 0. Okay, so you don't incur. So as you can see, this is the fixed cost. So you don't incur the fixed cost if you don't produce anything. You only incur fixed cost if you are not producing anything. This idea is different from general concept of fixed cost. So remember when we studied short run, we said that capital is fixed. So R K bar is something you have to pay even if quantity produced is 0. Even if you don't produce anything, you still have to pay your fixed costs. And that became a reality during COVID time. Okay, so we all might have known somebody who has a business wherein they're not producing anything, yet they have to pay the fixed cost of the land and whatever other things that they have taken license for such situations. But here we are making an assumption that if you don't produce, you don't have to pay this fixed cost. Okay, so you pay this fixed cost. Suppose this is some sort of a license fee which you have to pay up only if you're producing. If you don't produce, you don't have to pay this license fee. Okay, so that's the idea, that if you produce, you incur this fixed cost of P1, otherwise you don't. So find the cost function of the firm. So that is what I'm interested in. Now, first of all, MC2, if Q2 is greater than 0, obviously, because if Q2 is 0, then there is no cost itself. For Q2 greater than 0, MC2 will be equal to 2. Right? So when I equate these two things, I get Q1 equals to, okay, okay, no, okay, sorry, I made a mistake. This marginal word should not have been. This is cost of operation and a cost function of C1 equals to 2. So C1 equals to 2. So MC2 for Q1 becomes equal to 1. So these two things, they become equal for Q2 equals to 2Q2 equals to 1, which implies Q2 equals to 1 by 2. Okay, so let's consider a simpler situation wherein you uh, have no fixed cost. Okay, assume this fixed cost is not present. Okay, so forget this fixed cost for now. So right now we have these two numbers. MC2 is 2Q2, MC2 is 1. So this is similar to this sort of a situation. Okay, where one SIM card's calling keeps on increasing, whereas the other SIM card's calling is constant. Okay, so let's represent this with the help of a graph. So if I were to draw a graph here, so MC1, MC1, MC1 would be a constant 1, whereas MC2 will be an increasing function. And they are going to be equal for this value, half, 0.5. This is Q2, this is Q1, this is MC2, this is MC1. So what do you think? How will a firm forget this fixed cost for now? Okay, forget this fixed cost. I'll introduce this later on. Just tell me, how will the firm distribute its total quantity Q in this situation, where these are the marginal cost functions. So how will the firm distribute its quantity?
So Q2 will be 1 by 2, it will be constant, and then
Yes.
Q1 will be Q minus Q2.
Well, so Q1 will be equal to capital Q minus 0.5. Very good. So irrespective of how much it wants to produce, if the total quantity is greater than half, okay, so the first half unit gets produced in plant 1 because that is cheap. If you have to produce, let's say, just 1 by 4 units, you are going to produce it completely in plant 2. But if you have to produce more than 1 by 4 units, then you will probably look to plant 1. More than 1 by 2 units, then you'll start looking at plant 1. So the first half units get produced in plant 2. The remaining, all the units, they go and get produced in plant 1. Okay, so is that clear to everyone? So by doing this shifting, suppose capital Q is greater than half. So how much savings does plant 2 cost? Okay, so I'm saying that suppose that plant 2 is functioning. So what is the savings that you are incurring from plant 2? So had plant 2 not been operational, this half unit would have been produced in plant 1. So the cost of producing this half units in plant 1, since the marginal cost of plant 1 is fixed at 1, the cost will be 1 into half, which is equals to half. So this would have been the cost of producing this half units in plant 1. The actual cost of producing this half units in plant 2, okay, so this half units produced in plant 2 is just area under the marginal cost curve, right? This is the marginal cost curve. So you just integrate this marginal cost curve, Q1, this MC2 is 2Q2. 2Q2 going from 0 to half. So integration of 2Q2 is Q2 square. Rather, they have already given you the cost function, so you can put it there. But the point is, this is the cost. Okay, for this discussion right now, I'm assuming fixed cost away, fixed cost 0. All right, so right now, don't think of fixed cost. I'll introduce it. Right now, I just want to say in variable terms, what is the benefit of producing this half units in plant 2? So going from 0 to half, so that is equal to 1 by 4. So right now it's costing 1 by 4 rupees to produce in plant 2. If you were to shift this entire production in plant 1, it would cost you 1 by 2 units. So savings is equals to cost in plant 1, cost to produce this half unit minus cost in plant 2, which is basically half minus 1 by 4 equals to 1 by 4. This is the maximum savings that you incur by producing this half units in plant 2. Now I'll introduce the fixed cost. Okay, so if you start the plant 2, the variable cost that you save is 1 by 4. But the fixed cost of running plant 2 is rupees 1. So it's like saying that so this is a typical question of should you buy an electric vehicle or not? So buying an electric vehicle is a huge fixed cost because electric vehicles are typically 5 to 10 lakhs costlier than their fossil fuel versions. But you save on marginal cost. So somebody who is not driving a lot, he does not find it worthwhile to buy an electric vehicle because it's not going to make much profit for you. It's not going to make too much savings. So it's a similar thing here. So my question is, will you start plant 2 in this condition? In this condition, would a profit maximizing producer start plant 2 at all?
No, sir, because the savings will exhaust in this case.
Yeah, exactly. So even assuming that you're producing a huge quantity, you will never go beyond 1 by 2 units in plant 2. So the maximum savings in variable cost that plant 2 can give you is 1 by 4. But starting this plant itself is costing you rupees 1. So instead, what you will do is you will not produce in this plant, you keep it idle. Okay, you will not produce anything in this plant. Okay. So that begs the question, what is the maximum fixed cost below which the firm finds it profitable to run plant? What is the maximum fixed cost at which you might, at some level of production, want to start plant 2?
So 1 by 4.
Very good. 1 by 4. 1 by 4 is the maximum. So if fixed cost goes anything above 1 by 4, you don't want to produce in plant 2 you don't want to produce plant to use plant to add cost. Okay. So I have this question coming from here. Suppose fixed cost equals to 1 by 16. What is the minimum quantity of production, capital Q, for which plant 2 will start? This will require some calculation. So I'm saying now fixed cost. Obviously, I have already established that if fixed cost is above 1 by 4, I'll never run it. But you need to think that if fixed cost is 1 by 16, but the amount of quantity that you want is, let's say, 1 by 100. Let's say the demand is 1 by 100. So you just produce this 1 by 100 in plant 1 and you sell it. Why do you even want to start plant 2? Because the fixed cost 1 by 16 is greater than the production cost in plant 1, which is 1 by 100. Okay. So my question is, when fixed cost is 1 by 16, obviously for a very small level of quantity, you don't want to produce, you don't want to start plant 2. So what is the threshold quantity, capital Q, at which you decide to start plant? Maybe I should give you these figures. Cost in plant 1 is Q1. Cost in plant 2 is 1 by 16 plus Q2 square for Q2 kilocalories. Maybe you'll get some ugly quadratic. You find that quadratic and leave it at that. That is sufficient for me. I'm not giving you, I'm not here to test if you can solve quadratic functions or not. I'm here to guide you to that quadratic, which you need to generate. Is anyone getting anywhere with this so that I give you more time? If everybody has dropped their pens, then if there's anybody who needs more time, please let me know. Otherwise, I'll start discussing it. Okay. So here at the threshold, obviously for quantities very low, he wants to prefer producing in plant one because now he doesn't want to incur this fixed cost. For quantities very high, typically greater than 1/4 or something, he is going to want to produce in plant two. Okay. So at some threshold quantity, cost of producing in plant one will be equal to cost of producing in plant. All right, because now the quantity is so low that he does not want to use both the plants. Obviously, it's below 1/2. We know that till quantity equals to 1/2. If plant 2 is running, he will produce the entire quantity in plant 2, if plant 2 is there. So my quantity is less than 1/2, but greater than 0. So somewhere in between, he decides to start the plant, right? When he decides to start the plant, since this quantity is less than half, he will shift the entire production from plant 1 to plant. So below this threshold quantity QT, below QT, C1 of producing everything in plant 1 is better, and above QT, till half at least, producing everything in plant 2 is better. So the production of this entire quantity in plant 1 is going to be QT. This should be equal to production of this entire quantity QT in plant 2. So 1/16 plus QT square. So that is basically your answer. So I don't want to solve the quadratic like I told you. So let me uh, try to solve the quadratic here. Solve it. So this can be resolved as QT square minus QT plus 1/16. So my ABC are 1 minus 1 and 1/16. So I'm just going to put those values 1 minus 1 and 1/16. It is 1/16. Uh, 1/16 in decimal terms is what? 0.0625. Yeah. So the roots are 0.933 and 0.006. So obviously I'm looking for a quantity lower than half. So this is not the root that I'm looking at. The root that I want is 0.066. Okay, so 0.066 is roughly what, 2/30. Roughly speaking, 0.6067 is, so it's 2/30. So 2/30 is the quantity. Roughly 2/30 is the quantity at which you will decide to start the second plant. Okay, so below 2/30, you don't start plant 2, and above 2/30 till half, you produce only in plant 2. So your entire production plan Q1 comma Q2 will be equal to capital Q comma 0 if capital Q is less than QT. It will be 0 comma Q if capital Q, if QT is less than equal to capital Q less than equals to half. And again, it will be capital Q comma half if QT is, if capital Q is greater than half. So you start by producing everything in plant 1, then you shift all production to plant 2. Okay, first only plant 1, then only plant 2, and then if quantity is sufficiently high, you will produce in both plants. So initially plant 2 is shut down, then plant 1 is shut down, and then both plants. So interesting thing.
Excuse me, sir.
Yeah.
So can you please, like, I didn't understand what is QT.
QT is that threshold quantity at which you decide to run plant, start plant 2. So you see, if quantity is too low, obviously I will not start plant 2. Why? Because I have to incur a fixed cost of starting plant 2. If I don't have sufficient demand, if only 1 by 100 units are to be produced, I can produce it in plant 1 by giving 1 by 100 rupees. Why should I pay a fixed cost of 1 by 60? So obviously for a very low quantity, I will only run the show in plant 1. At some point, I will find it profitable right now to start plant 2. So here the question is, what is that point where I start getting an incentive, profitable incentive to start plant 2, and that quantity I'm representing as 2.
Okay, sir.
The important thing is this equation, that when I decide to start the second plant, producing everything in plant 1 and producing everything in plant 2 is going to be the same thing. I'm going to be indifferent between producing everything in plant 1 or producing everything in plant 2. So this is the important equation. Although this fixed cost thing has never been asked by any of the exams, but increasingly I see over the years that they delve into much difficult types of problems. So I expect them to maybe ask it at some point in the future. Hopefully your time would be the one, because you guys are trained with it. Your competitors will not be trained with it. Okay. In the another example, suppose the cost functions are q1 square and 1 plus q2 if q2 is positive. So now the fixed cost is shifted to the linear cost function part and 0 otherwise. So find the cost function of the firm. Okay, by the way, the final step here is finding the cost function. So cost as a function of q will be equal to capital Q if q is less than qt, 1 by 16 plus q square if q is greater than qt, and no, if qt is less than capital Q is less than half, and for q greater than half, it's going to be, oh no, this is capital Q minus half and half. Yeah, so capital, so this cost is going to be q minus half, plus this cost is going to be 1 by 16 plus qt square. So that is 1 by 16 plus 1 by, okay, so that is your complete characterization of the cost function. Okay, so I have given you the entire cost function in terms of just one variable, and that is q, capital Q. That's all. Okay, let's look at this problem now. Now, cost of firm 1 is q1 square, cost of firm 2 is 1 plus q2. Okay, so cost of firm 1 is q1 square, cost of firm 2 is 1 plus q2. So the first question is, for what quantity, or rather ignoring uh, fixed costs, what is the savings on max savings on variable cost from plant. What is the maximum savings that you can incur from plant 2 You don't need to solve here, by the way. Just think about it. Think about marginal costs, how they are behaving, and maybe the answer will appear. Okay, marginal cost in plant 1 is 2Q1. Marginal cost in plant 2 is 1. So obviously, marginal cost in plant 1 is going to keep on increasing, right? So if you did not have the option of producing in plant 1, sorry, option of producing in plant 2, your marginal cost will keep on increasing forever. So what will happen is that for Q very, very high, all additional quantity will be produced in plant. So the max savings, there's no upper bound on savings here. The savings keep on increasing if you keep on increasing the quantity. And because if you remove the option of plant 2, then your marginal cost in plant 1, it keeps on increasing. Right? So the savings are very high. So one thing is clear from here, that for very high Q, plant 2 will always be operational irrespective of the fixed cost. So even if you make fixed cost as 1 lakh, but at some point you will be finding it profitable to produce in plant 2 if the quantity demanded is high. So this is something different from the previous case, because in previous case we said that if fixed cost is greater than 1/4, you will never produce in plant 2, irrespective of what quantity you're fixing. But here, for some threshold quantity, you will always produce in plant 2. Okay, so beyond that threshold quantity, plant 2 will always be operational. So let's start delving into this problem. Again, the problem is the same: find the cost function of the firm. So my question is that for fixed cost equal to 1, as is given in the question, at what quantity QT will the firm start plant? At what quantity will it first start plant? So when it decides to start plant 2, the cost of producing quantity QT in just plant 1 should be equal to cost of producing quantity QT in plant 1 plus plant 2. So this is something which is different from the previous case. Because in the previous example, what was happening is that when I reached QT, I would stop producing in plant 1. I would shift to producing in plant 2. Here I won't do that. Can anybody tell me why will I, even when I am willing to pay this fixed cost, why will I keep running plant one? Look at the marginal cost values. That will give you the answer. Why do I keep running plant one even when I've started plant two? Think about the SIM card examples.
So because the marginal cost lesser for some values of Q.
Very good. For Q values less, Q1 values less than half, marginal cost of plant one continues to be lower than marginal cost of plant. This is not something which was happening in the previous case. In the previous case, I established that quantity QT was less than half. So in that case, marginal cost in plant one was always greater than marginal cost in plant. So here it's like you're buying a second SIM, which is a postpaid SIM. Let's say you have to pay some fixed cost on that SIM. If you pay the fixed cost, your calling rate is 1 rupee per call. The other SIM card, you have a calling rate of 25 paisa, 50 paisa, 75 paisa, 1 rupee, and then onwards. So if you're making, if you are not making enough calls, it makes no sense to get the recharge, get the second postpaid SIM running. You are okay, pada rehne do, you will not recharge it. But once you recharge it, even in that case, the first 4 calls are still cheaper on SIM 1. You will use them. Okay. So you still continue to use them. So that's the idea here, that even when you have crossed your threshold, it's not like you stop using plant 2. So what is the cost of producing a quantity QT in plant 1? So that's going to be QT square. And what's the cost of producing the same quantity QT in a mix of plant 1 plus plant 2? So assuming that plant 2 is running, it's going to be 1 plus Q2 plus Q1 square. Obviously, I don't want to leave it at Q1 and Q2. I want to resolve Q1 and Q2 in terms of QT. So suppose plant 1 is running. So if plant 1 is running, you've already paid this 1 rupee. So now how do you divide the quantities between the two plants? So that will come from marginal cost. So MC1, MC2. So 2Q1 must be equal to 1, which implies Q1 must be equal to half, which implies Q2 must be equal to QT minus half. So I'm going to make these substitutions here. So this becomes 1 plus Q2 is QT minus half plus 1 by 4. So that is QT plus 3 by 4. So your final equation for threshold quantity is QT square equals to QT plus 3 by 4, or QT square minus QT minus 3 by 4. 3 by 4 is basically 0.75 is equals to 0. So I substitute that in my quadratic equation solver, minus 0.75. So the roots are 1.5, no, 1.5 and minus 0.5. So obviously 1.5 is the one I'm looking for. Okay, so I'll give you some questions in the test like this. Don't waste your time doing the quadratic. I'm fine if you just go online and search for quadratic equation solver. Okay. If you can solve it, great. I do not see the point, frankly. I mean, it's a good exercise. If you can do it on your own, great. If you can't, at least reach the quadratic. That is important right now. Reaching the quadratic itself would be a task, because as you can see, these are a little complicated questions. So implies QT becomes equal to 1.2. So for a threshold quantity of 1.5, you would be you would be basically starting plant 2. So beyond QT 1.5, you are going to start plant. So the total production plan now, capital Q1 comma Q2 becomes equal to, right? So if total quantity is less than 1.5, you are going to produce the complete thing in plant 1. So capital Q comma 0, right? And when total quantity is greater than 1.5, then you are going to produce, as we have seen, Q1 is half, Q2 is Q2 minus half. Or rather capital Q minus half generally. So half comma capital Q minus half. Okay. So that's it. I'll give you some more problems. Think about them. Do these problems again. You should be able to do them again. So that will boost your confidence about doing them in the test or later on. Okay, so let's move to some conceptual things now. Profit maximization. So the aim of any firm is to maximize profit. What are profits? Profits are revenues minus costs. So I represent profit as pi, revenues as R, cost as C. Revenue can be written as price into quantity, but price, I am assuming, is a function of quantity. So this is your revenue minus cost function. So cost is also a function of quantity. So everything is a function of quantity. Now, if I just write my profit as pi equals to revenue as a function of Q minus cost as a function of Q, then differentiating with respect to Q for profit maximization. So we learned about optimization. Optimization means you differentiate and equate to 0. So that is likely to be an optima. So d pi by dq equals to 0 implies dr by dq minus dc by dq must be equal to 0, which implies dr by dq, which is your marginal revenue, must be equal to dc by dq, which is your marginal cost. So marginal revenue equals to marginal cost is true for all producers. Generally, we try to think that it is true only for a monopolist, that for a competitive firm, it is price equals to marginal cost. But as we'll see in later discussion, for a competitive firm, marginal revenue becomes equal to price. So it's not that marginal revenue is marginal cost is not true. That is also true, but in competitive market, marginal revenue becomes equal to price. So price equals to marginal cost is also correct for a competitive firm. But marginal revenue equals to marginal cost is true for all firms, be they in a competitive market, an oligopolistic market, or a monopolistic market. So this is some example of, let's say, some MR equals to MC curve, right? So what I'm going to do is basically the slopes of these two things are going to be equal. MR equals to MC. So when I look at the slopes of cost curve and revenue curve are equal. So they are equal at 2 points here, at Q double star and Q star. But obviously the actual thing is revenue minus cost. Here, revenue is down, cost is high. So revenue minus cost is negative. Here, revenue minus cost is positive. So this is the maxima and this is the minimum. So when you have multiple solutions to your MR equals to MC, then you will have to go to second order conditions and check which is the maximum, which is the minimum. Like in this case, you have the R minus C curve as convex here. So this is a minima and this is concave here. So that's why this is a maximum. But usually in my experience, it has never come down to second order conditions. So you can save time in exam and ignore second order derivatives. You can just stick with first order derivatives and solve it. All right, a word about marginal revenue. What do we have? Yeah. So marginal revenue is basically revenue is P of Q into Q. Okay. All right. So revenue is P of Q into Q, which implies that marginal revenue dr by dq by using my product rule is going to be P prime of Q into Q plus P of Q. Okay. So P prime of Q is nothing but dP by dQ. So, and this is just P price. So I take P common here. So I can take P common here and write this as P times dP by dQ into Q by P plus 1. Now remember from our discussion on elasticity, elasticity used to be dQ by dP, sorry, dQ by Q upon dP by P, percentage change in quantity upon percentage change in price. So another way to write this would be dQ by dP into P by. Now if I compare this term with this term, I see that this thing is just reciprocal of this thing. This is dP by dQ into Q by P. This is dQ by dP into P by Q. So this is basically 1 by. So what I get is in the end that marginal revenue becomes equal to price times 1 by elasticity plus 1. Now price is always positive. So the sign of this thing depends on the sign of this. So if 1 by E plus 1 is greater than 0, then you will have marginal revenue greater than 0. Which implies 1 by is greater than minus 1, which implies E is less than minus 1. Now, marginal revenue is nothing but dr by dq, that is positive. Dr by dq positive means that as quantity increases, revenue increases. Now, E less than 1, is this elastic or inelastic? Think about it and tell me, is this elastic or inelastic? Basically, elastic demand is when mod of E is greater than 1. And inelastic is mod E less than 1. So is this elastic or inelastic?
Elastic.
Very good. This is elastic because this is 0, this is minus 1. E less than minus 1 means it is here, which is basically mod E greater than 1. So this is the elastic zone for demand. So when demand is elastic, marginal revenue is increasing. So if demand is elastic, then marginal revenue is positive or revenue is increasing. Sorry. Marginal revenue is positive. So this is an important relationship between elasticity and marginal revenue. This is an example here. Suppose a firm faces a linear demand of Q equals to 100 minus 10p, show that the marginal revenue is always less than price. So the demand function is Q equals to 100 minus 10p. So I can write price equals to 10 minus Q by 10. So revenue equals to P into Q, which is basically 10 minus Q by 10 into Q. So that is 10Q minus Q square by 10. Right? So marginal revenue will be equal to dr by dq, which is equal to 10 minus 2Q by 10. Now remember, from this equation, price equals to 10 minus Q by 10. So if I compare these two things, I can establish that marginal revenue is less than price, because you are subtracting a larger quantity from marginal revenue. You see, you're subtracting only Q by 10 from price, but you're subtracting 2Q by 10 from margin, from 10 in marginal. So marginal revenue is less than price. The importance of this thing is that if you are, let's say, selling in a market in which the price of this pen is suppose 1 rupee. Okay, so this pen, it costs suppose 1 rupee in the market. Okay. So if the cost of this pen is 1 rupee, or let's say 10 rupees, if I produce one more unit of this pen, the additional revenue that I'll generate from selling one more unit of this pen will be less than 10 rupees. That is the idea. At any point, whatever is the price, the marginal revenue is going to be less than that price. Because as soon as you increase production by 1 unit, the price in the market falls down to accommodate that one extra unit of production which is happening right now. So because the price in the market falls down, the marginal revenue will not stay constant. It will be lower than the price. But it is approximately constant for competitive firms. So we are going to assume marginal revenue equals to price. Price does not depend on what you produce and all these things. Right. So final thing is price marginal cost markup. So marginal cost is equals to price into 1 plus 1 by E. We already established this. We have seen this. So price upon marginal cost. Okay, so since I know this, I know MC by P equals to 1 plus 1 by E, which implies that P by MC equals to, or this can be written as 1 plus E by E, or P by MC equals to E upon 1 plus E. Okay. Now, price, a markup of price over marginal cost is P minus MC by MC, which is basically P by MC minus 1, which will basically be equal to E by 1 plus E minus 1, because P by MC is E by 1 plus E. So that would be equal to minus 1 upon 1 plus. So this is your markup formula, and it depends on just elasticity. So if you have the elasticity of demand in a market, you can find the markup. We'll look at this formula again when we reach ASAD in macro. In macro, we are going to see these formulae.